The average car battery has a lifespan of 5 years with a standard deviation of 0.3 years. Assuming a normal distribution, if a factory makes 70,000 batteries in a year, how many of them will last longer than 5.5 years? So the first thing to notice in this problem is that we have two very important words. One is average, and the second is standard deviation, which means that we're talking about a statistics problem here. So the first thing we should do really is draw our normal curve, label our mean, and the x that we're looking for. So as you can see, I've put 5 in the middle of my curve. I've put 5.5 to the right of it because it's greater. And we're going to shade what the problem is looking for, which is how many of them will last longer than 5.5 years, which means this is the area that I'm shading in right now that the problem is actually looking for. So the first thing to take note of is that since 5.5 is to the right of 5, your z-score should automatically be positive. So we know that we're looking for a positive z-score. So let's go ahead, we'll pull up our formula for our z-score and we'll calculate it. So here we have z is equal to x minus mu over theta, where mu is the mean and theta is the standard deviation. So for our purposes, we now have z is equal to 5.5, that's our x, minus mu, our mean is 5, over 0.3, that's our standard deviation. When we compute that, we get 1.66666, which we round to 2 decimal places, and that becomes 1.67. Now remember something important. 1.67 is not the answer to the question. This is just our z-score. If you want to then go ahead and find the area, you have to actually pull up a chart, and any statistics book or any test you have is going to give you the area chart based on your z-score. So when we look up 1.67 on our chart, we find that we have the number 0.9525. So the corresponding area for 1.67 is 0.9525. Here's the thing though, you have to remember that the area that we get is always to the left of our x, which means that this is the area that is 0.9525. But that's not what we're looking for. We're looking for this area. So if you want to find the area that the problem wants, you have to go ahead and you have to subtract the 0.9525 from the total area, which is always 100%. And when we do this, we get 0.0475. So that means that this area here is 0.0475. That's the area that we have. However, that's not the answer to the problem. That's just the area of the region that's greater than 5.5. The question now says, if a factory makes 70,000 batteries a year, how many of them will last longer than the 5.5 years? Well, the way that we're going to find this is we're going to take those 70,000 batteries and we're going to multiply them times the probability that a given battery will last. And when we multiply 70,000 times 0.0475, we get 3325, or 3,325 batteries. That's how many of the batteries out of the 70,000 that are made in a year will last longer than 5.5 years.